We shall now discuss about those integrals that yield inverse hyperbolic functions. So here are the formulas that we will be using. The integral of du all over the square root of a squared plus u squared is inverse hyperbolic sine of u over a. The integral of du over the square root of u squared minus a squared is inverse hyperbolic cosine of u over a plus c. The integral of du over a squared minus u squared is equal to 1 all over a inverse hyperbolic tangent of u over a plus c, where u is less than a. Next, the integral of du over a squared minus u squared is 1 over a inverse hyperbolic cotangent u over a plus c. Now, u is greater than a. The integral of du over u, the square root of a squared minus u squared, is equal to the negative of 1 over a inverse hyperbolic secant of u over a plus c. And finally, the integral of du over u, square root of a squared plus u squared, is negative 1 over a inverse hyperbolic cosecant of u over a plus c. You notice that in all the formulas, the formulas involve the terms a squared and u squared, where a is a constant and u is a function. So in each of these, after identifying the function u, you have to check on the differential du. We also notice that these formulas are similar to those formulas that yield the inverse trigonometric functions of inverse sine, inverse tangent, and inverse secant. Okay, so we need to memorize these formulas and we must know how to apply them correctly for a given integral. So let us now work on some examples. We can copy this. Okay. So for the first one, let us evaluate the integral of e raised to 2x dx all over the square root of 1 plus 9 e raised to 4x. So we focus our attention in our radicand. It is of the form a squared plus u squared. So that means that our a is 1, our u is 3e to the 2x. We check the differential, which is 3 times 2e to the 2x dx, or 6e to the 2x dx. So let us complete this as 6e to the 2x dx times 1 over 6 over the square root of 1 plus 9e to the 4x. So it is of the form du over the square root of a squared plus u squared. So our answer here is inverse hyperbolic sine of u, which is 3e to the 2x, all over a, which is equal to 1 plus c. Or we just write this as inverse hyperbolic sine of 3e to the 2x plus c. Right? So let us have another one. The integral of dy all over the square root of 4y squared minus 5. So we take note of the radicand 4y squared minus 5. This is of the form u squared minus a squared, where a is equal to the square root of 5 and u is equal to 2y. Then we check our du, which is 2 dy. We rewrite our integral dy all over the square root of 4y squared minus 5, and we complete our differential, so 2 dy times 1/2. And the answer is forthright. This is of the form u squared minus a squared, so the answer is inverse hyperbolic cosine of u over a, 1/2 inverse hyperbolic cosine of u, which is 2y, all over a, which is square root of 5 plus c. Okay, we can write this as 1/2 inverse hyperbolic cosine of 2 square root of 5 over 5y plus c. We evaluate the integral of dt all over 2x minus x squared, or it should be 2t minus t squared. Alright, so what we are going to do here is we will complete our denominator as a perfect square trinomial by first factoring -1. So negative quantity t squared minus 2t. And then we complete this. 2a is -2. We divide -2 by 2, which is -1, and we square it. So -1 squared is 1. So we have just added +1 preceded by a negative sign. So the added term here is -1. And to counter that, we have to add 1. Alright? So now we have integral of dt all over 1 minus t squared minus 2t plus 1 is t minus 1 squared. Alright? So 1 minus t minus 1 squared. With t minus 1 less than 0, then that will yield 1 over a, or 1 over 1, inverse hyperbolic tangent of u, t minus 1 over a, which is 1, plus c. Okay? We go to our fourth example, the integral of dx all over x plus 2, the square root of x squared plus 4x plus 5. So we see a term outside our radical, and we suppose that this is our u. So what we need inside the radical is u squared. And to form the term u squared in the denominator, or more particularly in our radical, what we do is we complete this x squared plus 4x as a perfect square trinomial, and that is by adding 4. But since the original constant is 5, let us just write 5 as 4 plus 1. Next, dx over x plus 2 times the square root of x squared plus 4x plus 4 is now equal to x plus 2 quantity squared. And that is exactly the term we need. Na? We need u squared inside u is x plus 2 and then plus 1. So it is of the form du all over u square root of u squared plus a squared, or a squared plus u squared. And that gives us negative 1 over a, or negative 1 over 1, inverse hyperbolic cosecant of u x plus 2 all over a, which is 1, plus c. Okay. For our next example, we evaluate the integral of sine theta d theta all over the square root of 5 minus 4 sine squared theta. We have our radical 5 minus 4 sine squared theta. We may take on 5 as our a squared and 4 sine squared theta as our u squared. With u squared equal to 4 sine squared theta, our u is 2 sine theta. If we are to take the differential, it will be 2 cosine theta d theta. But there is no cosine function appearing in the integrand. What we have is sine theta. And we know that sine theta d theta is the differential of cosine theta, or the differential of negative cosine theta. So what we will do is we will create a function cosine inside the radical. And we can do that by applying an identity to sine squared theta, which is equal to what? Sine squared theta is 1 minus cosine squared theta. And let us see what will happen. We have sine theta d theta all over the square root of 5 minus 4, that will be 1, and negative 4 times negative cosine squared theta is positive 4 cosine squared theta. So what we have in the radical is the expression a squared plus u squared. So it's not really a squared minus u squared, but a squared plus u squared. Alright? So our a is still 1. Our u is 2 cosine theta, and du is negative 2 sine theta d theta. So the only thing we have to do is to introduce negative 2 and multiply it by negative 1/2. And our integrand now will be of the form du over the square root of a squared plus u squared, which of course is equal to inverse hyperbolic sine of u over a. So our answer here will be negative 1/2 inverse hyperbolic sine of u, which is 2 cosine theta all over a, which is 1, plus c. Okay? So, one final example. For our final example, let us integrate 1 plus 3x quantity dx all over the square root of 9x squared minus 4. So for this integral, let us split this into 2, dx all over the square root of 9x squared minus 4, and then plus 3x dx all over the square root of 9x squared minus 4. For the first integral, dx over the square root of 9x squared minus 4, it is of the form, or the radicand is of the form u squared minus a squared, where a is equal to 2, u equal to 3x, and du is 3dx. So the first integral is of the form du over the square root of u squared minus a squared. And the answer for that is inverse hyperbolic cosine. Alright? We only have to complete our du, which is 3dx, and then 1/3. So that will be 1/3 inverse hyperbolic cosine of 3x, that is our u, all over 2, which is our a. For the second integral, the appearance of x dx tells us that our u is the entire radicand 9x squared minus 4. So we take 9x squared minus 4 as our entire u, and your du is 18x dx. So we have already x dx. We just introduce 18 and multiply it by 1 over 18. So that will be 3 times 1 over 18, and then du over, this is actually du all over u to the 1/2, or u to the negative 1/2 du. And by the power formula, it becomes u to the positive 1/2 over 1/2, or 9x squared minus 4 to the positive 1/2 over 1/2 plus c. So our answer is 1/3 inverse hyperbolic cosine of 3x over 2 plus 2 goes up times 3, that will be 6 over 18, and that is 1/3. And 9x squared minus 4 to the 1/2 is the square root of 9x squared minus 4 plus c. Okay? So, let us have some exercises. You work on the following. The integral of x dx all over the square root of x to the 4th plus 2x squared plus 2. Then the integral of dx over square root of 4 minus 9e to the 2x, and then number 3, 2x plus 5 quantity dx all over x squared plus 6x plus 8. Okay, so work on this and then we will discuss the solution.